Let's discuss question number 16 from test 10. This is from heat transfer. So what is given? A resistance wire of 1200 watt hair dryer is 80 centimeter long. So you have a wire. Let's model it like this. The length is 80 centimeter and the diameter is 0.3 centimeter and the wattage for this is 1200 watts. Okay. So determine the rate of heat generation in the wire. So this is your wire, resistance wire. All the hair dryer is your resistance wire. So determine the rate of heat generation in the wire per unit volume and the heat floods on the outer surface of the wire as a result of this heat generation. Okay, so now at steady state, whatever the heat that is generated has to go out, has to be dissipated. So at steady state we can write that the heat generated is equal to the heat dissipated. Otherwise the internal energy will build up and the temperature will rise. Okay, so first bit what is asked is the heat generated per unit volume. Now we know that the wattage is 1200 watts. One of the important principle in the resistance heating is the entire electric work is gone up in order to increase is basically the heat generated, because the entire electric work is the heat generated. It goes into the entire power dissipation. So the heat generated is 1200 watts and per unit volume is 1200 watts by the volume. So volume of this is volume of the wire is your pi by 4 d square is the cross section into length L. So this is the volume. So this you will get watt per centimeter cube. So pi by d square is 0.3 whole square, length is 80. So if you calculate this, you'll get close to 212.20 watt per centimeter cube. So the closest answer is 212 watt per centimeter cube. Now what is asked is heat floods on the outer surface. Okay, so as the entire 1200 watt has to be dissipated, that is dissipated from the outer surface. So the outer surface has to dissipate 1200 watts. So the heat floods, if you want to write per unit surface area, the outer surface has to dissipate 1200 watts. The amount of energy that has to go out from the outer surface is 1200 watts by the surface area. Now, surface area for the outer surface is, because it's cylindrical, so pi d is the circle perimeter into L is the total lateral surface. So 1200 into pi 0.3 into 80. So this comes out to be 15.915 watt per centimeter whole square. So this is close to 15.9. So both the answers 212 and 15.9. Let's look at the option. The option for this is A. Thank you.